Hey, this is Flux with Fluxwithit.com, and we're going to check out Rossum Electro Music, new Eurorack modules. And before we get into the actual new modules, I want you to tell everybody a little bit about who you are and where you came from and all that good stuff.
Sure, I'm Dave Rossum. I'm probably well known in the industry as the founder of EMU Systems. Over 45 years ago, we came up with the name EMU here down at Caltech when I was a student. And EMU built great modular systems back in the 70s and then made the transition into digital synthesis. We made wavetable synthesis practical. And since then, I've missed the music industry so much that after a 4-year hiatus, I'm back in it. Founded with my partner Marco Alpert, Rossum Electro Music, and the first thing we decided to do was come into Eurorack.
Excellent, excellent. Now you have a host of new modules. You didn't come with just one module. Why don't you start explaining what the idea behind the modules were and why you chose what modules you did?
Sure. The first module that we have is called Evolution. It is an all-analog module, and I chose that one to be the first one. Some was just because I have not done analog design in quite a while. That I've been doing sophisticated digital design, and analog design it's kind of like composing music. It genuinely is an art. I've always loved doing it, and this was an opportunity to get back into that and tweak the sound, get into that sort of organic space and so on. So I just had a great time doing that. That module is based on Bob Moog's ladder filter that he invented back in 1965. And EMU in our modular system had the 2100 module, which was based on the ladder filter. In 1973, I invented a new output stage for the ladder. There was an improvement in my mind over Bob Moog's design. It was lower noise, and there was some distortion in Bob Moog's output stage. I really wanted the EMU module to just have the inherent distortion in the ladder. So that was the original idea when we started building up Evolution. We put on the obvious things of voltage control, of resonance, and then started getting into more subtle things. We put a VCA in front of and a complementary one behind the ladder so that you could adjust the degree of drive within the ladder. And ultimately that is turned into something we call the species control, because we found that by doing some nonlinear stuff at about the midpoint of the range of that voltage control, you can get some really interesting effects, and it behaves in a very nice, musically useful way. The original Moog filter and the EMU both have the characteristic that as you turn up the resonance of the filter, the gain of the low-pass part of the filter goes down. So we added a Q compensation control, so you can choose to what degree you want that to happen, from not at all to exactly like the Moog and the EMU used to do. And then the final thing we did was the original Moog filter and the EMU were 4-pole filters. That's 45 degrees of phase shift at the cutoff. It's the classic place to put it. But my partner Marco asked me, could we do voltage controlled slope? And when I told him, you really can't do voltage controlled slope because the poles are real, I got to thinking about it and came up with this crazy idea of steering current around the ladder in a certain way and making the number of poles voltage controllable in a nice continuous analog way. Prototyped it up, and it just sounded so cool we had to do it.
So will that allow you to smoothly go between poles?
Exactly, but it still is kind of quantized, as we'll hear when we listen to the thing. Because the way the resonance works in a ladder filter, it depends on the phase shift in the filter. What happens is you get one resonant lump, and as you transition the number of poles, this one pops down, this one pops up. And again, in this kind of smooth analog way, so you've got quantization of where the resonance is, and then a nice transition between them as you sweep it around. That's voltage controllable, it's controllable at audio rates, which of course does its own interesting thing, and it just sounds cool. I mean, you have to hear it.
Now, where is the manufacturing being done on it?
For our first module, we've chosen WMD to do our manufacturing. William there was exceedingly helpful in getting us into the subtleties of Eurorack stuff and so on, and we're very, very pleased.
That's a great group to pair up with.
Yeah, he's just been great with us. We're happy to be in his booth here. He's just taken care of us. So
Can we talk about Morpheus?
Sure. The next two modules, and they're only in prototype. I should make it clear that Evolution is in production at WMD right now.
Okay.
They'll be coming into the stores in about a week and a half.
What's the price point on it?
The price point on Evolution is $369 retail. So the other two modules, they're both in prototype form here at the show, varying degrees of development. They are called Morpheus and Control Forge, and they're both based on ideas out of the EMU Morpheus synthesizer that we built back in 1993.
Sure.
The Morpheus filter is the actual Z-plane filter. If you look at the module here, you can see that we have all of the 246 different Morpheus filter cubes. We've extracted the data out of a Morpheus ROM, and so it will be based on actually those filters that were designed by the brilliant sound designers that EMU contracted with years ago. And the filter, on the other hand, if you remember, Morpheus was able to morph in real time in one dimension. The other two dimensions of the morph were chosen at note on time. With Morpheus, we have real-time control at the sample rate, so you can do full audio rate modulation in all three, the frequency, the morph, and the transform dimensions. So you can move around anywhere within the cube. If you're looking at the video and it's showing it, you can see the little fly moving around inside the morph cube here. That will be able to go at an arbitrary rate. And then you construct within the Morpheus presets that'll use a Morpheus filter. Then you can program that for some subsection of the cube. So you can essentially choose the origin and the gain of the three different control voltages. It's a stereo filter, so that filter will be applied to both a left and a right channel. You'll be able to choose the gain for the filter on each of those, because some of them Morpheus filters have a ton of gain at resonance. If you put them in too much, they'll really pump out the output and probably clip. So you want to be able to adjust that. And then we are hoping to be able to also give you a transition time, because the next level hierarchy is the preset sequence. So you can line up a bunch of those presets and under trigger control step through them or manually step through them with the knob here in a performance situation. And so you'll actually then, in addition, be morphing between one cube and the next cube as you move forward. So that's a pretty complete description of...
Where did the idea for this sort of display come from?
We knew we needed a display and just went shopping and picked out this OLED display. It's not unreasonably priced, and we just thought it looked really good. We've been very happy.
What's the power consumption on this?
I think this draws somewhere about 80 or 90 milliamps off of the +5 supply, and probably 20 or 30 off the minus supply. I just recently designed in a higher spec audio converter, and I don't remember the exact numbers on it, so I can't give you the exact numbers.
What is the audio rate that this is running at?
It'll run at the 48 kHz sample rate, the same rate that the Morpheus ran.
And that's 16-bit, or?
It's actually 24-bit.
24-bit.
Actually,
okay.
The converters are 24-bit, and then the math is all being done in floating point. That's the one other thing I wanted to say. The Morpheus filters, back in the 1990s, nobody knew how to build a filter that was unconditionally stable over arbitrarily time-varying coefficients. Since then, my colleague Dana Massey and Max Matthews, one of the very fathers of electronic music, worked together on something called a phasor filter. It uses complex math, and the phasor filter can be proved to be unconditionally stable no matter how you modulate the coefficient. So we're changing from the H-chip math into the phasor filter math, and then modifying what's called the armadillo coefficient encoding to work with the phasor filters. And that is all working. I've got that down, happening in MATLAB. It's just a matter of porting the code. That's probably, I'm dying to finish that code because I'm so excited about hearing what this thing's going to sound like.
Do you have a price point that this is going to be set at?
It's going to be a bit more expensive than the Evolution, but we haven't got final price points. But it's not going to be unreasonable.
And are we talking like a summer release, or like how soon?
We're saying that they'll be out in spring. Whether it's early spring or late spring, we don't know.
Sure.
Depends a little bit on how the rest of the development goes and so on. but I'm pretty confident they'll be out before summer.
Yeah, that's the one that I'm actually really excited for.
Everybody's jazzed about
And
that.
I really want to know about Control Forge as well, because this thing looks fantastic.
Well, Control Forge is also a spin-off of the Morpheus module. Morpheus had something with the relatively mundane name of function generator in it. And when we were looking at the Morpheus, which the Morpheus was an obvious thing to do, my partner Marco said, that function generator, the people in Eurorack would just love that.
Yeah.
And so we spent a lot of time at the blackboard working out how you would adapt that into the Eurorack world, and Control Forge is the result. It is a 8-segment function generator. Based on the original Morpheus, it has curves. There's a family of about 60 different curves in here, from simple exponentials through interesting little kinky shapes here to zigzags and chaotic shapes. These are all accessible as individual segments, and each segment also has conditionals, so while you're running in a segment, you can, based on control voltages or triggers coming into the thing, move back to a previous segment, forward to another segment, follow your regular rules either on an immediate or at the end of the segment basis. You also can string together the segments with a degree of randomness, relative or absolute modes, have programmable triggers as well. And once again, there's a hierarchical structure. So after you've constructed a preset, and a preset will typically have the form of either an envelope type thing or an LFO or some combination thereof, there's a sequence of presets that so you can have in all of these things, there'll be just a very large number of presets available, and a very large number.
And you could step through them with CV?
Right, with CV, so the thing can trigger itself and become a sequencer, or you can trigger it with your sequencer, however you want to do it. They're all trigger programming here. And then the whole thing, we also have time scaling control voltages, and the knob up here is a live time scale. You see I've sped up the time scale there and slowed it down here.
Excellent. And when is this one expected? Is that also spring?
This is also spring. Here you can see we have the real-time code running. What we haven't done yet is the preset editing code for this guy.
Yep.
And we have a companion module over here. It is just a mock-up for the show. There's no electronics behind this. But what Satellite will be is the functions of the Control Forge, but without the display and the programming interface. So you'll patch from the trigger output of a Control Forge to the logic input of a Satellite, tell the Control Forge hey, you talk to Hugh and tell him your program, and now you've got all the capability of the Control Forge in the Satellite in a much smaller form factor and less expensive.
So if you want to take one with you for a live performance, you can do that, and then you can have that in your big studio setup.
Right, or you can afford to put 3 or 4 of these.
Yeah, sure.
But you have both the space available, and it will be a step less expensive because the display isn't there, and so on and so forth. It won't be real cheap because it's going to have the same processor, and the accuracy of these things. That part of the philosophy of Rossum Electro is to really make quality panel components, quality circuitry. So this guy, the control voltages are accurate down to a millivolt. It's as good as your ear can hear pitch. Similarly, the 8 of these, are all within a couple of millivolts and things like that.
Very nice.
We add a little bit of cost to doing it, but it's the right way to do it, and that's what I love to do. So
excellent. All right. Well, listen. We're going to be checking out these modules later on as well when they get a little bit closer to release. And so check it out. It's Rossum Electro Music. Thank you.